So, hello everyone. I hope I'm audible. So, it would be nice if you can let me know in the comment section that if I'm audible or not. Please let me know in the chat section. All right. So, we'll start in another 3 minutes. Until then, if you have any questions for me, you can just let me know in the chat section. So, yeah, before going into the live, I would like to show you all the next video which is going to come up, because the project which I did was something asked to me, but the model which I worked on was pretty amazing, and that is currently the state of the art model. And it has also surpassed Mistral, because it is a fine tuned version of Mistral. Like I said, it has surpassed Mistral, but not just Mistral, it has surpassed Llama 270 billion also. So let me show you a glimpse of what is the next video. And hi, Mick. Thank you, man, for letting me know that my audio is clear. Which large language model is good for sentiment detection? A good question. Um, you see, Mick, it is not needed for you to always have large language models, but if you are going to go for large language models, try with some smaller variants of large language models. Let's say, for example, um, Flan-T5 is a good model, and it has given pretty good results. For me, Flan-T5 is one of the underrated LLMs, because it has shown great potential in variety of tasks. And if you don't know, I'll be obviously explaining about Flan-T5 in this live. And for those who have joined now, hello everyone. I'll continue your question, Meg. So before going on to that, I'll just give an introduction of what is going to be there in this live. I'll be showing about what is Flan-T5, why I'm just using it whenever I'm going for a encoder decoder or sequence to sequence model. I always go for Flan-T5. I'll say why it is that, and I'll explain about the potential of Flan-T5, which is not shown usually. And followed by that, I'll be collecting every dataset online for each task. And make don't worry, even sentiment detection is also there in that. A kind of sentiment detection, not exactly. And followed by that, I'll show how to process it for the task, and then we'll be seeing how to fine tune it. That will be the end of this live. For inference, I'll be updating the code, and the code will be available in the GitHub so that you can all see it. Why I'm not going to show the inference is because the training itself will take some time. Okay, so it will take around 40 to 50 minutes. So post the live, I'll try to fine tune it, and then I'll update the inference code. But I'll give the inference code in this live itself, because previously for one of our videos, which is Flan-T5 chatbot, I've shown how to fine tune it. So I'll show the same inference as well. Okay. So yeah, and again coming on to your question, Mick, yes, Flan-T5 should be good enough for you. So before moving on to the today's live, I guess we have around 30 seconds. Let me show you what would be the next video. All right. So like I said, I'm gonna show you how to fine tune a model which has surpassed Llama 270 billion actually. So yeah, here is the final output. Here it is. You can see, right? I've just said that you are a support chatbot who helps user with queries, user queries, chatbot who always respond in a style of professional. These are all some system prompt. But here the question is, I have said that I have a question about canceling my order number, and it has said that I'll assist you with that. To cancel your order, you can reach out to the customer support team. They will guide you, and this is one of the result. But trust me, when I played with the temperature parameter, it gave better results actually. But yeah, this is the best result which I attained till now whenever I fine tuned a model. Without going on to the code, I will show you about the training. Okay, that is something you need to see. See, usually we'll get a loss of around 1.5 or 1.6. That is what happens. But here, if you see, the loss was also 0.6 because the model has tremendous knowledge. All right. So yeah, I hope you all will be excited for the next video. If you are excited for the next video, let me know in the chat section so that I'll know that okay, you'll like these kind of videos. Okay. So yeah, first let me take 2 minutes of questions. Any questions? And once I load the data sets, I'll take questions again, and then followed by that we'll have a questionnaire once we completed the training. Okay. So if you have any questions, just let me know now, or else keep your questions coming in the chat section. I'll answer it before the live ends. Okay. So here is one question. Flan-T5 versus Mistral 7B. I'm confused. So many models coming up, but still Flan-T5 still is popular. Yes, still Flan-T5 is the best model when you come to encoder decoder. Okay, so there are other models as well. Like you have Mistral, Llama. These are all under causal LM. Okay, these are all sequence, not sequence to sequence LM, and sequence to sequence LM has its own advantage. All right, so that is why Flan-T5 is still kind of popular. So yeah, I guess that is all the chat, and yeah, seems like Mech is looking forward to the next video. Yeah, keep being interested. It is coming up in next 2 to 3 days. I've already recorded it. Just editing is pending. All right. So yeah, let me go on with today's video. Okay. So this is the model which we are gonna use, which is Flan-T5. All right. You see, there is this one capability for Flan-T5, which is it can be fine tuned for any number of tasks, which is n number of tasks at a single time. Okay, let's say you have a model which needs to do around 10 tasks by itself. All right. So at that time, you can fine tune Flan-T5 itself, and it will do any number of tasks at that single time itself. Okay. So that is the true potential, which is making Flan-T5 stand out of others. Actually, this is something which is there in T5 architecture itself. And why Flan-T5 is more popular is that if you see, Mistral 7B, more than Mistral 7B, Mistral 7B Instruct is more popular, and OpenArca now is also popular because these are all some instruction tuning dataset. Usually, the model's performance increases with instruction tuning, and Flan-T5 is the first instruction tuning model which was released, if I'm not wrong. Okay, because you'll find it very crazy. I found it very crazy when I just knew about it. It was fine tuned on 1800 tasks at a single time. Okay, so that was Flan-T5 actually. Okay, so the ability of that to generalize its knowledge, see, that is all about Flan-T5 actually. So here you can see, right? Let me explain about that. Here they would have tried for n number of tasks, and it will try to generalize those knowledge for a new task, for whatever unseen tasks it has. It will try to generalize to that specific task. Let's say for example you have conversation summarization as our use case. Okay, you have conversation generation, and then you'll have something like summarization both being trained. Okay, and for conversation summarization what happens is it will try to understand, okay, this is how I need to summarize, and this is how conversation it is, and then I'll try to summarize it. So this is how it works, if that helps for you for understanding how cross task generalization happen. So where can we see GitHub or notebook link so we can do hands on? um yeah, I've just created the notebook. So for now the notebook is not provided because when I edit, if you edit it, it will become a problem. But yeah, since I'm doing everything from scratch, you can just create your own notebook in Google Colab, just create a new notebook and then you can just follow me for hands-on. All right. I hope that helps, Mick. So with that being said, I would also like to show you that, see here, these are the tasks which it has been trained on. So here you can see, right, 80 tasks, 1554 tasks, 9 from chain of thought fine tuning, and there is T0 SF in which there is 193 tasks. On total, it was around 1800. Okay, 1836 tasks, which is falling under 146 task categories, and that is why Flan-T5 is still popular. I hope the person who asked me that question would know the answer by now. Okay, so yeah, that is about Flan-T5. If you want a separate video explaining about this paper itself, just let me know in the chat section. I'll try to make a separate video on Flan-T5 architecture itself, because for that I need to teach about T5 architecture. Followed by that, I need to explain about the fine tuning which they follow. Okay, we are not going to dive deep into that, but now you know why Flan-T5 is so popular, because it can be fine tuned at one time for a number of tasks. Okay, but this is not going to be something like a conventional instruction tuning. Here you will be using something called prefix. Okay, a prefix will be provided, and based on that, that prefix will have the knowledge. Okay, this is the task which I'm going to do. The prefix will have that knowledge, and we are going to see how to do that. Okay, so that is what this video is all about. So yeah, in this I'm gonna use Flan-T5 large, which is a pretty good model. Okay, it is not the best model. If you want to get the best performance, this is not the best model, but yeah, Flan-T5 large does the task. Okay, so let me go to the notebook first. Okay, so here you can see, to just reduce time, I've found some dataset for different tasks. I'll explain each task in a minute. I'll explain one task, and then we'll go on to go on to this dataset, and I'll followed by that show how to process it. Okay, so first task I have considered is text classification, for which we are going to use dar AI emotion. Okay, I'll show the dataset as well, so you can just paste it here. Dar AI emotion. Dar AI is an organization, and they have created this emotion dataset which is having a number of datasets. Okay, so this will need lot of processing. No problem, we'll try to create that. Okay, so we'll try to somehow process it, because if you see here, these are numbers but we need string. All right, so we'll see how to process that. You need not worry about processing at all. Next we have MLQA HAEN. Why it is like that? See, let me show you. MLQA. Okay, so there is this dataset known as MLQA, and inside that there is this model known as MLQA HIEN. See, the good part of this dataset is that you'll have the context in Hindi, question in English, and the answer will also be in Hindi. Even this model can do that. So to show that potential, I have also had added this dataset. Next we have squad, which is used for question generation here, but the same can be used for question answering also. All right. Oh, sorry. And then we have pause, which is for paraphrasing. All right. So pause is this pause is this data set, sorry, from Google themselves. Okay, so this is a pretty good data set, which is you'll be having one line and then there will be another line. Okay, so these are two lines, so there are two sentences. You'll be converting one sentence into another without changing its meaning. Okay, so here also there will be needed there will be some processing needed, but yeah, you get the sense, right? So text classification, it is to classify the text, be it any text category or emotions. Text classification is all about classifying by understanding the semantics inside the text and the structure as well. So question answering is given a context, or even at times without a context, you should answer a question. So given a context, you should generate a question. That is about question generation. And for paraphrasing, if you see, it is a form of translation actually. Okay, so you have one sentence and you have another sentence, you'll be converting one into another. So, but it is not language translation here, but it is kind of semantic translation rather. Okay, not semantic, maybe structural translation, because you are just changing the structure of the sentence, but the semantics remain the same yet. All right, so that is about paraphrasing. Next, translation. Unlike usual language translation, here I have considered code to text. Okay, so given a code, it will try to generate text, but we can also do text to code or any other things. Okay, we have Samsung, which is for dialogue summarization, and text generation. We are going to generate poems here, and for checking the model's reasoning capability. Uh, Reasoning is one of the weak fortes of LLMs, if that helps. So we have seen that previously. So yeah, we are going to fine tune for that aspect as well, where we'll be checking the mathematical reasoning capability of the model. Then for the same of semantic similarity, how similar it is, we'll be using the same POS data set. And then we have table to text, for which we are going to use gem. Okay, so inside gem there is lot of data sets, and I'll show you which we need to use. And for finally MCQ, for which we'll have choices, and then we need to answer the question based on the question context and choices. So that is about MCQ question answering. And yeah, we'll also see that. So possibly, if you see, I've covered almost every task, and if you even have a new task, it will whittle down into some of these tasks itself. Let's say you have natural language to SQL query, it becomes translation, right? So yeah, I've carefully created that. So yeah, if you have any use case, you can use this specific project itself. So you can just follow this video, and then you can just create the model for your use case. Okay, so if you have any doubt, let me know in the chat section. I'll be more than happy to answer your questions. Okay, so the first step would be is to download the data. Okay, so once I put download data, um I'll be answering any of your chat questions you have. Okay, so keep your questions coming, and I'll try to answer any of the questions, because it will take some time to download. And yeah, if you have any general questions, also let me know in the comment section, rather the chat section here. All right, so here we need some dependencies. So let me install the dependencies here. Okay, we have installing dependency section. We are going to have a code cell for installation. Pip install datasets, transformers, and then we also need what, datasets, transformers, possibly accelerate, peft. These are some things which we need. All right, just give me a minute. So yeah, sorry about that. Now we are doing some installations. Okay, uh yeah, with the installation, once it is completed, we'll start downloading the datasets. Okay, from datasets, we need to import load underscore dataset. All right, we'll go dataset by dataset now. So guys, if you haven't created a Colab notebook yet, just create a Google Colab notebook, and just do hands-on with me. Okay, so before going on to that, there is a question here from Mick. MCQ is a QA based on given text or paragraphs. Yes, but here, unlike usual question answering, it will also have the quest choices along with the paragraphs. Okay, so that is the difference here. Now we need to import load dataset. Okay, that is being imported. First is, and then yeah, we will need dataset as well. There are some other dependencies. Dataset import pandas as PD. Okay, so these are some imports which is basically needed for pre-processing the data set. Okay, so that are important now. Now the first would be, first data set is dar AI emotion. Okay, let me paste this here. So here you can see there is split and unsplit, and there is train, validation, test. In every task we'll be considering just 500, because obviously we need to have reduced size, right? But I would recommend you all to not do that. Okay, so just do for whole data set, but not now. Probably after the end of the live you can try to run it for the entire data sets. Okay, so for now here I'm just going to consider the test. Okay, so let me show you how to process the data now. Rather, import and then download and process. We have dar AI slash emotion, which is text classification. All right, in this we need, uh, I'll write it as text underscore classification underscore data is equal to load underscore data set of, sorry, load underscore data set of dar AI emotion, comma, it is split, right? So the you should mention the subset. So next we have split is test. So this is how you need to load it. Okay, let's see the text classification underscore data. So now it will download the data. All right, the only disadvantage is it will try to download the whole data, and then what happens is then only it will try to download the script. Yeah, it is now completed. It is fast. That's cool. Now let's see how it works. So let me create a markdown here so that we can use this. Okay, text classification. Inside that, next is to see this data. Okay, so let me convert this into a pandas data frame. Df is equal to te- text classification underscore df is equal to text underscore classification underscore data dot to underscore pandas. Okay, so this is the data set. All right, we have it here. I'll show you the data set now. So here there are labels, right? So let me see if there is any being provided here. Joy, sadness, and 6 classes are there. So we'll need to create a mapping. Okay, so sorry, we'll change it as download and process data. All right, so yeah, we have the mappings here now. Okay, let's see if there is anything being provided here as specification. Okay, anger, is anger 0? No, nope, there is no mapping being provided. So here it is. Yes. Okay, so here is the label. All right, I just have it here. So what we are going to do is we are going to create a dictionary so that we can map it. Okay, I'll just have a dictionary here at the bottom. Map underscore emotions is the dict. Okay, inside that we'll have 0 as surprise. Yeah, sadness. Sorry, sadness. 1 as joy. We have 2 as love. We have 3 as anger, and then sorry, 4 as fear. Finally, 5 as surprise. Okay, so this is the dict which we need to use so that the label columns is ready. The main thing which you need to notice, we need to have all under a single name. Okay, so the column should be in a single name so that we can merge those and have it as a single data frame finally to provide to the model. So we'll be using source column named source and target column named target. Okay, so let me go to this text underscore classification underscore df of target is equal to text underscore classification underscore df of label dot apply. You're gonna apply lambda x is to map. Okay, that should be right. Map underscore emotions of x. Okay, so basically what happens is it will try to find the value of 0, which will be sadness here, so it will be replaced. Okay, so that is what happens, and then we'll have text underscore classification underscore df of source to be text underscore classification underscore df of what is that text. Okay, so these are the two columns, and then finally we'll be having only the source and target. Okay, source and then target. All right, so next let's see if this is good. Okay, yeah, now it is cool. Okay, so here I'm just gonna sample. Here it won't work obviously, so let me sample just 500 rows. Okay, so text underscore classification underscore df is equal to text underscore classification underscore df of df dot sample of 500. Okay, so hopefully guys, again, don't expect performance with my training which I'm doing now. Okay, like I said, don't do any sample. Okay, just fine tune it for whole data set. Don't do any sample, don't reduce the amount of data, and you should be good enough. Okay, so you should be good with a very good model. Okay, so instead of using 500 point data points and all, just use 5,000, 10,000, doesn't matter, and train it for longer times. It will work as good as any model. Okay, so yeah, let's go for the next data set, which is mlqa. Okay, MLQA. HIN. Yes, here it is. Okay, so we have here the next data set, which is for question answering. All right. Yeah, I forgot the main part actually. Um, so what shall we do? Yeah, we can run from here. All right. Text dot apply. Guys, like I said, task prefix is very much important. Okay, so I'm gonna add the task prefix now. I was just thinking what I forgot. Okay, text underscore classification underscore emotion. Okay, so this is the label, and then we are adding it to the prefix. Okay, so this is how a prefix work. You should just try to name the task somehow. Okay, and then just add it here. Okay, so this is how it should be, and this is the task prefix which will enable the model to know, okay, so this is how I need to do the task. Okay, so here I'm expecting a text classification, because if you see here, I just didn't provide any instruction stating that I need to do text classification and all. This prefix will say that I need to do text classification. That is how the model learns. Okay, so here we have text classification. Next, we need to load the MLQA dataset. Okay, so MLQA, inside that we need to load mlqa.hi.en. Yes, mlqa.hi.en, and then we have validation, which is 507 rows, which is exactly what we are going to use, right? So let's use that split itself. Split is equal to validation, guys, but you can just remove it and add the test and validation splits together and then use it. Okay, data sorry qa underscore df is equal to data dot two underscore pandas, and then we have qa underscore df being printed here. Okay, so here we need context, question and answer, right? So what we are going to do is we are going to again use apply function. Okay, so qa underscore df of source is equal to qa underscore df of, sorry, context comma question. We are gonna use apply function. Okay, so lambda x is to process, yeah, I think that should be better. No, it's not needed. We'll have it as multi so mlqa question answering. Okay, we'll have it like that, question answering. Rather, we'll have it as more explanatory, context question answering. Okay, so try to have it as explanatory as possible, so it will be helpful. Okay, so we need to add this in front of context, right? So before adding that, you also need to add something like this, context is to. Okay, and then add your context plus x of context, and then we'll add another simple space, and then we'll add x of question. It's not just space, we also need to have a question prefix so that it will know this is the question. Okay, so this is how we need the data to be in the source. And as far as target is concerned, qa underscore df of target is equal to qa underscore df of answer answers dot apply lambda x is to. So here you can see there is a dictionary. So let's call the text alone from there. Okay, it is x of text, and then inside that it is already a dictionary, sorry, list. Okay, so we don't need list, we'll have this alone. Okay, and here it should be specified axis equal to 1 so that it will traverse those columns. When you are using multiple columns, you should specify the axis to be 1. Okay, finally we'll have qa underscore df to be qa underscore df of source, sorry, source comma target. All right, qa underscore df, we'll have it. See, now question answering is also done. So yeah guys, if you have any doubts, keep just asking me. Okay, I'm more than happy to take it. Okay, so let's go for the next task. Here the next task is squad, right? Based on that we need to generate question answering, question generation. Okay, so yeah, I'll format this notebook and provide it, okay, so that it will be easy for you all to use it. So now let's go on with squad. So guys, do you like this kind of live session, and do you want more of these live sessions, like probably once in a month, even for general discussion, probably for half an hour on whatever is trending in AI? So you want to discuss something with me, just if you are interested in that kind of live session, just let me know in the chat section. Try to um I'll try to have these sessions. So yeah, just let me know in the comment section. Can the code be shared too fast to follow along? Yeah, like you see, I'm coding in live, right? So there is no way I can share it right now. Um, so yeah, probably try to follow along. If not, just try to understand what is going on, and then post the live session. You can still have the code and do it. Okay. So once the live is ended, as soon as the live is ended, I'll try to have your code there. Okay, yeah, sorry. Yes, once in a month is good. Okay, let's plan a live. And yeah, I also have an interesting idea for the live. So yeah, we'll discuss about that sometime later. Okay, not in this live. So yeah, with that being said, now the next is to generate the questions. Okay, so data is equal to load underscore dataset of squad v2, which we are going to use here. Inside that we are going to use validation. Okay, split is equal to validation. Did I do? Yeah, spelling is wrong. D what is this? Q question generation. Okay, let me write it as qgen underscore df is equal to data dot to underscore pandas. Okay, also we'll try to take only 500 rows. Okay, qgen df is equal to qgen underscore df dot sample of 500, so that we can reduce the computation. Okay, we'll try to see the qgen df. Okay, so hopefully it will come now. So a kind request to everyone, just share this live with your friends, community, and whoever you think this live might be useful for. Also, let me know your feedbacks of this live in the comment section. Okay, so that is a kind request from my side. And most importantly, like this video, because that is how YouTube works, right? The YouTube recommendation algorithm will try to recommend videos only if there is a lot of views and likes, and for me to reach more people, it is not possible without you guys. Okay, so that is a request. Now, yeah, this is there, but there is no answers. So why it is that? That's need to be seen. um Usually there is no answer, so probably I'm not just gonna take it here. There are a lot of empty values there. Okay, so let me take the top 500 itself. Fusion underscore df is equal to qgen underscore df of is to 500. Okay, now hopefully it is not empty, but I can see something empty here. It's fine. We'll try to do it in the processing itself. Okay, first is creating the source shouldn't be a problem, so let's do that. But yeah, I just didn't think of it. We need to have only answers, right? So let's do sample itself. Sorry guys, I'm just doing it in live, so I'm just thinking out in live itself. Okay, we are just gonna generate questions, so there is no need for answers. All right, unless and until the question isn't empty, we don't have any problem. Okay, by this way we'll have different context and different questions for different context. Okay, yeah. So now we are going to consider only context and question, with context being in the left and question alone will be the right. Okay, so now how we need to process is qgen underscore df of source is equal to qgen underscore df of context dot apply of lambda x is to question generation. Let me have it as context question generation itself. Context question generation plus x. X, yeah, that is all needed here. And I'll copy this, I'll paste it here. I think there is no need for anything here. So yeah, target would be question. Okay, so yeah, hopefully now we have something which we expect to have. Okay, so target the q and qgen df, it will be here, right? So let's print that now. So guys, three tasks is completed already. We are 45 minutes in. Just let me know in the comment section, do I need to do for all tasks, and or shall we just consider five tasks and we'll just fine tune for that five task, because it will take some time, but it's on your choice. If you think we can do for all tasks, then yeah, I'm in for it. We'll go for all tasks. Okay, because already I've shown how to do question answering, question generation, text classification. Okay, um so summarization, translation and paraphrasing should be of the same. Okay, um text generation, it is more like um text generation would be more like a general thing, like you can use text generation for any task. So basically everything is generation of text. So yeah, you can see text generation to be of any task. Okay, so yeah, let me know in the comment section, rather the live chat section here. Until then, I'll try to do for uh, paraphrasing, and then I'll also do summarization, but let me know if you want for others as well. Okay, so for paraphrasing we need pause, right? So let me go to pause here. We have pause, and inside that, if you see, we have different splits here. We are just gonna take labeled final. Inside that, we'll take validation. All right, so let me see. um, is 0 a contradiction or 1 contradiction? So here it is, although interchangeable and not interchangeable. Okay, so 0 is contradiction and 1 is entailment. So we'll go for 1, and then we'll consider those data set alone for translation. So paraphrasing basically is a kind of translation. Okay, so even code to text you can do in this way, and also for other languages. All right, so yeah, let's download this data set. Data is equal to load underscore data set of pause. Inside that we'll be using labeled final, right? So labeled underscore final, and then we have split to be validation. Okay, split is validation. Okay, so what is this paraphrasing, right? I'll write it as trans itself so that we will know this is also a kind of translation data frame. Okay, so translation data frame is equal to data dot to underscore pandas. Okay, trans underscore df is equal to trans underscore df dot sample of 1000. So you'll understand why I'm sampling 1000 at the later time. Okay, error will come. Yeah. um Guys, let me know in the chat section, right? Shall we do for all the tasks then? So yeah, we only need data which is of label 1. Okay, so that is why I sample 1000. Trans underscore df is equal to trans underscore df of trans underscore df of label equal to 1. I hope this should work. Let's see. Sentence 1, which should be our source, and then we'll have sentence 2, which is target. Okay, so yeah, it is seem to be working, I guess. Yes, it is working. Okay, so here you can see, right, in July 2017, in July 2017, and the label is 1 here. Okay, so yeah, we'll have this data frame again processed as trans underscore df of source is equal to trans underscore df of sentence 1 dot to underscore, sorry, dot apply lambda x is to paraphrase. That's all, paraphrase plus x. Okay, so trans underscore df of target is equal to trans underscore df of sentence 2. Okay, so now we have the translation data frame being ready. All right. um why is it, okay, I didn't take those alone. It's not good to be here. Try to overwrite it. So trans underscore df of source comma target. Trans underscore df is equal to. So this is the translation df which we need. Okay. Now, even if you see in core tasks of NLP, right, we have covered 1, 2, 3, 4 tasks, which is core. Next, we'll go on to another core task, which is summarization. Okay. Unlike usual archive or daily mail summarization, I thought let us do something different, which is conversation summarization. Okay. But yeah, the code remains the same, the processing way remains the same. At least when you're doing this hands on with me, I guess you will all know how to do this kind of processing, right, for each task. So yeah, um let's go for Samsung. Here we have Samsung, in which there is dialogue and summary. So let me take the test split alone. All right. Yeah, let's consider this. Data is equal to load underscore dataset of Samsung. The split is test. Okay, and then sum underscore df is equal to data dot two underscore pandas, and sum underscore df will be considering only first 500. Okay, sum underscore df. So yeah guys, now we are in summarization. Oh, there is an error. We need to install a library, it seems. So let's install that here with install pi7izr. Probably the dataset inside should have been a zip. Okay, so that is why it is expecting pi7izr. All right. Yeah, hi Abhinesh. Welcome to the live. Hopefully you'll like this. Okay, now the installation is done. Hopefully now it should run. Okay, let's see. It is running. Yep, it is running. So yeah, we have 500. Okay, so the dialog would be our input and summary would be our output. So how we are going to do is sum underscore df of source is equal to sum underscore df of dialog dot apply lambda of x is to. So here what we are going to do is conversation summarization. We are just letting know that we are summarizing the conversation. Okay, and inside that we are adding dialogue. Okay, so that is how our input is going to be, and output, it is not going to be somewhat a large number of processing being needed task. Okay, sum underscore df of summary. All right, so finally we will have sum underscore df to be sum underscore df of source and target. Okay, so now summarization is also done. Next, what is the task being pending? I've just lit it so that we can close it here. Okay, summarization is done. Next is text generation, followed by that we have reasoning. Okay, so let me see text generation first. We'll go on to reasoning next. Here you can see uh, basically what you can do is you can just write a poem, write a poem to complete this. Okay, so that is how you can do, though that's why I've kept it like this. Okay, here you can see, right, just complete the poem, something like that. And then there was time when talk of love, and then it will try to complete it from here. Okay, so yeah, let's do it. mm, Maybe what we can do is we can take some 10 tokens, 10 first tokens, and then from there we can try to tell that the model should generate the poem. Okay, so that is a good way. So let's do text generation here. Okay, so we have text generation. First, we have load underscore dataset, and then inside that we are going to use the train split, right? So we'll have split to be train. Okay, so the split is train now. Df is equal to, sorry, tgen, rather, text gen underscore df is equal to data dot to underscore pandas. Okay, text underscore gen underscore df dot sample 500. So that should be our text gen df. Okay, so the next is to create a function. Possibly this will take some time because yeah, it will take some time for sure. First what we'll do is we'll try to create a function. Okay, def home splitter. Okay, of text, and inside that what we are going to do is we are going to make a random split. Okay, so first we'll split the data set and then make a list out of it. Okay, let me show you. Text underscore gen underscore df first. Text underscore gen underscore df of home dot split of, sorry, of 0 dot split. Okay, text gen df. Oh, I've just typed as def. Why not home of 0? Okay, let's do like this. Dot iloc of 0 of home. I hope this should work. Yeah, here you can see, right, by words it is just splitting. So what we are going to do is we are going to do the same. Okay, word list is equal to text dot split off based on space. Okay, for space we are splitting it, and then what we are going to do is we are going to take first n tokens and then we are going to say that complete the poem. Okay, so that is how we are going to ask the model to do. So yeah, source is equal to a list, Maybe we'll have a empty string. Okay, target is again an empty string. So what we are going to do is we'll import random here. Okay, so num words would be random dot rand int of 0 comma len of word underscore list. We are not going to take more than 2. Okay, so I'll flow divide by 2, only half of it. Mostly we'll try to ask the model to complete the poem only after it's half. Okay, that is the worst case, best case scenario. The worst case would be to ask it to generate from 1 token, so rather we'll have it as 10 here. Okay, at least I hope there will be 10 tokens in each sentence. Okay, so yeah, with that, what we are going to do is source is equal to word list, sorry, word underscore list of is two numbers. Now it will have a list. Okay, so what we are going to do is we are going to join it. Source is equal to source dot join of, inside that we are going to join this list. Okay, I hope this is how it works. Okay, what we'll do is let's test it out. Okay, a is equal to, sorry, code space dot join of a. Let me print it out. Okay, so yeah, that is how it is expected. Rather it won't be needed actually. Will not have it because we need to provide a space. Okay, so now it should work, and then we'll copy the same and have it for target. Okay, target, and I hope you would have all guessed it by now. It will be numbers is to till the end. Okay, and we'll return both of these. Return source comma target. Okay, so this is the function. Next what we'll do is we'll apply this on text in df. Okay, text gen underscore df of source. I hope we can get two values from apply function. If not, we need to have it in a single column first, and then we need to separate it again with another apply function. Okay, target is equal to text underscore gen underscore df of, what is the column name? It is poem. All right, so poem dot apply of lambda x is to poem underscore splitter of x. Let's see, hopefully doesn't an error doesn't occur, but if not, we need to sort it out. Yes. Oh, what happens? Empty range for run range. What? Is there an empty string here? Text underscore gen underscore df is equal to text underscore gen underscore df dot drop in a. Hopefully there is no empty string actually. Yeah, it is not there. Okay, let's make a foolproof approach. Okay, if len of word underscore list is greater than or equal to 10, then only we'll have numwords as random.randint, else numwords would be um we'll have these also there. Okay, what we'll do is we need to drop those, we don't need that, so we'll have it as source is equal to drop and target also as drop. Okay, yes, why is that? Is it you called random like this? Okay. But I've just had the word list to be greater than or equal to 10, right? Hmm. Rather, we'll have it as 0 itself here. Hopefully, that will solve the error. Let's try. Too many values to unpack. Yeah, now it's fine. Okay. We'll have this as a string, sorry, a list, and then we'll have um we'll have this copied because we'll need it at the later part. Okay, so first is text underscore gen underscore df of source. Inside that we'll have it. Okay, so now what we'll do is we'll have source is equal to, no, first we need to make it for target. Okay, first target is equal to text underscore gen underscore df of source dot apply of lambda x is to x of 1. Okay, next what we're going to do is for source we are going to just take the 0. Now we'll have the exact thing what we expect to have. Okay, hopefully now it looks good. Yeah, but I didn't add a prefix, so we'll add that. Okay, text underscore gen underscore df dot apply lambda x is to home completion is to plus x. Okay, so now the source is ready and target is ready for text generation. What's the problem here? um for now I'm just going to take string of x. I think there is some int value in there. Yeah, let me add it here itself. Home hyphen completion is 2 plus x of 0. Okay, let me see if it is working here. Yeah, it seems to be working. All right, we'll take text gen underscore df is equal to text underscore gen underscore df of source comma target. Okay, we'll take these alone. Yeah guys, text generation was kind of exhausting. All right, already we are running behind time, so what I'm going to do is we'll be doing the processing completely, but for code I'm just gonna paste code. I'll also paste it in the comments chat section. I'll paste the code from some of the previous project. Okay, hopefully that is fine by you all. Next, I'm having reasoning here, which is JSM 8K, and then table to text, and then MCQ. Okay, so we have GSM 8K, where it is here. So yeah guys, like you can see, right, that the coding part is not that tough actually. The part where you need to have a lot of time being spent is none other than the data creation part. Okay, guys, also I'm moving on to reasoning then MCQ. Let's do with that. Hopefully I have 10 tasks at least here. Okay, hopefully these are all fine by you all. Here we have 1 2 3 4 5 6 7 tasks, and then I'm gonna add obviously MCQ is going to be added, so 8 tasks. I guess it is good enough number. Okay, so data is equal to reasoning. It is not going to be something hard. You can just add a maybe probably question answering without context, something like that, and then it will work. Okay, so I'm not going into this reasoning also. I'll show you how to process some hard data sets. Semantic similarity, I'll just let you know how to do those. Okay, pause. um yeah, so for this what you can do is try to add a task prefix, something like sentence 1 to similarity, something like that, and then have sentence 1 is to sentence 1, and then sentence 2 is to sentence 2 in source, and then in target, in place of 0 have it as contradiction, and in place of 1 have it as entailment. Okay, so yeah, this seems something which we can try to do. Okay, so semantic similarity, it is usually known as NLI. Okay, so this is not a semantic similarity task, it is a part of NLI actually. So I'll have it as NLI. Data is equal to, we'll do it fast, load underscore data set of pause, and the split we are considering here is, yeah, test. Okay, we'll have test here. Last time I guess we used validation, so let's use test here. um NLI underscore df is equal to data dot to underscore pandas, and NLI underscore df is equal to NLI underscore df dot sample 500. Okay, now we'll have NLI underscore df labeled final. Okay, that is not added. labeled. Yeah guys, you can see right, the subset is not added yet. Guys, do you have any doubts till now of how you can process for a specific use case? If you have a use case in mind and you don't know how to process it, let me know in the chat section now. I'll be more than happy to take it, because most probably in 5 minutes we'll be completed with data processing and then we'll move on to coding. Okay. And yeah, so that, yeah, let me know if you have any doubts. All right. Um, yeah, we have it here. So what we are going to do is, what is the name again? NLI DF, right? NLI underscore DF of source would be NLI underscore DF of sentence 1 comma sentence 2 dot apply of lambda x is to. First what we are going to do is NLI, right? NLI um hypothesis check, something like that. Okay, something like that you should do. Then you'll have sentence 1, right? So inside that we'll add x of sentence 1, we'll be joining it. Okay, sentence 1, and then we'll have sentence 2 here, we'll have a space, then sentence 2, and then we'll add the sentence 2 as well. Okay, so yeah, now you have the source ready. Sentence white. Oh yeah, I didn't provide access equal to 1. Uh, so yeah, now the source is ready. Like in the text classification, now we need to create a map df, map underscore we'll have it as hypo underscore dict is equal to 0 is to contradiction, and then 1 would be entailment. Okay, entailment is something like both are similar, and contradiction means both are different. Okay, so we have NLI df, right? NLI underscore df of target is equal to NLI underscore df dot of label dot apply lambda of x is to hypo underscore dict of, sorry, x. Okay, so now we'll have the source and target alone. Underscore df. So yeah guys, now we are done with this also. Let me see if we need to do any other task. Okay, so we have table to text and MCQ. I'm not going to do MCQ. Let me have that for you guys to do. Okay, so I'll tell you how to do MCQ. So you need to like join context and question. After that, add a statement, something like the choices are, and then have these choices being added, stating that this is 1, this is 2, this is 3, this is 4. and then add the choices. Okay, so yeah, I'm not going to do that. Let me do the table to text also in a separate time. Okay, let's do that as a separate use case. We are not doing these now. Okay, and this is also not done. Other than this, everything is done. Okay, so most probably all the use cases completed. Okay, whatever use case you might face should start with this actually. So now it is to combine final data. Okay, for this what we need is we need to have the list of df names. Okay, so that we can concatenate all of those. Here we have text classification df, qa df. Okay, so I'll have find list of dfs equal to text underscore classification underscore df qgen df, I guess, if I'm not wrong. qa underscore df. Hopefully these are there. NLI underscore df. NLI is done. What is the name here? Text in df. Right. We have text underscore gen underscore df. Okay, so this is going on. I think this should be sum underscore df. Yes, this is sum underscore df. All right, so what I'm just going to I'm doing is we are going to combine all of these into a single data frame. Okay, so we have translation df, and then we have qgen df. I guess we have added it already, and then we have qa df. Finally text classification df. All of these are added. So let's check if we have 8. 1 2 3 4 5 6 7. Oh, what 7? Okay, we have 7 then. 3 6 8. No, 8 should be there. No, we didn't do reasoning. Yes, I didn't remove that. Okay, so these are the 7 which we have considered. 1 2 3 4 5 6 7. Okay, so now what we are going to do is final underscore df is equal to pd dot concat of list of dfs with the axis being 0. Okay, so hopefully now all is fine, and then we are ready to go on to code. Yes, all are fine. We have around 3500 rows as expected, because we have 7 tasks, and we have 500 in each, so 3500 makes sense. All right, so yeah guys, that is about data processing. Okay, so yeah, if you have any doubts, let me know first, or just give me a heads up that we can move on to the coding part of the model. Okay, so that we can fine tune it. And guys, don't worry, like I said, I'm just gonna use the previous code so that this will be faster. Okay, so that this live will be faster. And yeah, I'll also paste the code cells here. That shouldn't be a problem. Okay, so yeah guys, let me know. Until then, I'll try to create a class. Okay, so usually it is good to have class. Now let me open the Google Colab notebook of that. Okay, Colab, we have chatbot here. Okay, yes. um so yeah guys, this is the notebook which we are going to consider, and this notebook is also available in the GitHub, so I'll provide the GitHub link here. Okay, Let me show you the GitHub. So here you can see, right, there are lots of project in our channel, and the live started with this actually. Okay, so yeah, I'm providing this link in the description so that you guys also can follow along and do this hands-on. Okay, the link is in the description, so you can see here. This is the link. I've posted it, so you can use it. Okay, but I'm not just gonna use this. I'll try to make this as class probably. No, rather we'll go on with this approach itself. All right. So yeah, first these are the imports needed. I'll explain each of those. Okay. So pandas is obviously to have the data frame functions, and dataset class, it is needed for you all to interact with the dataset. Okay, so that is how dataset class is. Whatever you create in Hugging Face dataset, that will fall under this class dataset. Okay, and then auto tokenizer for tokenization, and auto models for sequence to sequence LM to create the model. All right, and guys, let me know if you can see the link, so that I'll know, okay, that the link is available. You all are ready for fine tuning. Okay, so auto model for sequence to sequence LM is needed for us to call the model, and then we have from PEFT we need LoRA config. Okay, so LoRA config is for us to create LoRA adapters, and then get PEF model will try to create a parameter efficient fine tune model. What it will do is basically it will try to take the original model and try to attach the LoRA adapters along with that. Okay, and then task type, actually it is not needed here. And then we have a sequence to sequence trainer because we are training a sequence to sequence model, and then we have the training arguments and data collator for the training. All right, so let's run this. Next is this one, which we won't need obviously because we are not gonna read this, right? But what we need is this one. Okay, train data, test data. I'll show you what you need to do. Okay, so I hope sklearn is there. From sklearn dot pre yeah, we need it actually. From sklearn dot pre-processing, import train underscore test underscore split. All right, hopefully it is there. Sklearn model selection, yes, not pre-processing. Yeah, we have it. So train underscore data. Before that we need to convert it into data frame. So data is equal to dataset dot from underscore pandas of final df. All right, so this is how the data will be created, and then now we'll no, train it won't work on datasets, right? I just forgot it, sorry. Train test split off from final df. Test size is 0.1. Okay, because we have very less number of data, so I'm just taking 1. And then we have a random state 0 and shuffle is true. Okay, so now we have train data, which is dataset dot from underscore pandas of train underscore df, and the same will be changed for test as well. Okay, so test underscore df here, test underscore data. Right, now we have the data ready. Now next is to create the model. Okay, We'll be using tokenizer and model, which is Google FlanT5 large. Okay, we are creating the model here. Now the model is being downloaded, which is around 3 gigs. So until then, I'll try to call these. Okay, here is our preprocess function. Let me take a time to explain this. So we have source here and target. Sorry, let me take a minute. So yeah, we have the source being tokenized here. We are setting the max length to be 256, and if the length is less than 256, it will try to pad it with some pad tokens, and then if it is greater than 256, it will try to truncate it. And same we'll do with the case of labels. Okay, what we'll do is in labels we need targets token IDs. Okay, so that is why we need labels. So we'll tokenize the target, and the max length we'll keep it as 128, and then again the padding will be true here, max length, which also can be set to true. Okay, and then truncation will be true, which will try to truncate if it is greater than 128. Padding again the same. If it is less than 128, it will try to match it. Okay, so yeah, now we are checking. It won't make any sense actually, but to write it again and again, rather than that, I've just kept it like this. Okay, and unless like copying it here max length and then pasting it here, I just had it in a parameter. All right. So if the padding, we'll check if the padding is max length, which will be true always. And then the label of input ID, what we'll do is we'll go through these labels, and if it is pad token, we'll keep it as -100. So the purpose behind keeping it as -100 is because when you do the training, right, it will try to ignore these tokens because it will give no value once you do -100. Okay, so if you do a softmax, it will become 0. All right, rather infinity, yeah, not 0, infinity. Now the time is to process these data sets. Okay, we'll have these. Now it is getting mapped. So here you can see, right, the train dataset has around 3000 data points, and test probably will have around 300. Okay, so yeah, now we are set to go with training because the tokenization is completed, and yeah, we are now also loaded the data. Next is to attach the LoRa adapters. Okay, so yeah guys, if you haven't watched the LoRa video, I recommend you all to watch because I've explained about these parameters in detail each. Okay, so each parameter is explained there. Left one thing here, target underscore modules. I'll explain this in a gist here, but for detailed explanation, you can just check the video. Okay, q comma v. So the LoRa rank is something which will try to determine the number of parameters you need to fine tune. Basically, LoRa is to train in the reduced number of parameters, still achieve the performance which full fine tuning does. So that is about LoRa. And here we are setting the rank to be 8. LoRa alpha, which is kind of a scaling parameter. Usually alpha is also scaling parameter, right? So LoRa alpha is also a scaling parameter which has a value of 16, and LoRa dropout is 0.1, bias is set to none. Task type we are setting to sequence LM. There is another type also known as causal LM, which we will be using whenever we have Mistral or Zephyr, these kind of models. All right, and then the target modules is which are the target modules I'm looking at for it to kind of attach the adapters. Okay, so yeah, I hope it makes sense. So we'll run this. All right, I'll also show you the model. Okay, first what I'll do is I'll print the model here. So you can see there is a lot going on. That's fine. So now we are getting the PEF model. Like I said, in get PEF model, we'll provide the model as well as the config, which we have provided. Now it will try to attach the adapters. And then here you can see, right, the trainable params is very much less. It is around 0.3% of the whole model. But trust me, the performance won't be that degrading. Okay. So that is the beauty of low rank adaptation. It is one of the state of that technique. And here you can see, right, under Q under V, which is attention layers, we have LoRa dropout, LoRa A, LoRa B, LoRa embedding. Okay, so that is why we attach this model. LoRa. That is how we attach this LoRa adapters. Okay. So next we have this one, label pad token ID. Like I said, it should know that -100 it is its pad token, so that we are providing that. Okay, and we are also providing the tokenizer model. Pad to multiple of 8 will try to pad in 8 sequences. Okay, now everything is set. So first we need to log into the notebook. Okay, so the important step is that you need to log into the hub. So for that we'll call this notebook login function from Hugging Face Hub. So I'll also show you how to create it. Okay, so new token, I'll write it as plan AIO all in one. Yes, and make sure that the role is right. Okay, so that you have right access. Copy this, paste it here. All right. So now you would be logged in, and then the next step would be to provide the training arguments. Okay, I'm gonna have it as Flan-T5 large AIO. Okay, so let's keep it like that itself. The batch size I have kept it as 6 per device. Train batch size means that in each device there will be 6 examples or 6 instances rather. Okay, so why it is per device is that here we are using collab which will have only single GPU, but you will have servers which will have multiple GPUs. So yeah, for that we are using only 6 batch size, but based on your consumption you can increase. But if you have, let's say, kind of 8 GPUs, so what will happen is 6 into 8, 48 would be your effective batch size. And then we have learning rate being provided as 2e minus 4, num train epochs is 1, so that we'll train for 1 epoch. And we are logging it in logging directory. Logging strategies, epoch, save strategies, epoch, report to tensor board. We'll have a tensor board finally. And then we are also setting push to hub is true, so that we can push this model to the hub. All right, I'll set this as well, and we'll call the trainer. Okay, it will take model, training arguments, dataset and data collator as well. All are ready, so we'll provide that as well. Actually what we'll do is we need to actually set the configuration of use catch to be true, so that it is said that okay, it is training, not inferencing it. Okay, so with the trainer being set, we are ready to call the train. I don't know how long it is going to take. If it is short time, I'll show it here itself, but I'm sure it will take a longer time. Oh, sorry, I didn't create a GPU instance. Guys, let's not run it again. Right, so if you call this trainer.train function, it should be able to train. Then what you need to do is you need to run this. Okay, what it will do is it will try to attach, rather push these models. Okay, the base model, the adapter model, which will be called from here trainer.model, and the tokenizer, all will be pushed into the hub. Okay, so I'll put this here, Flan-T5 large AIO. Okay, after this I'll take the questions. I'll try to probably run all of these. Okay, so yeah, what we'll do is change runtime type. I should have made it GPU from first. My mistake. No, it will again download from first. This will take a long time, guys. So yeah, if you have any doubts, let me know in the chat section. Okay. Hopefully this comes soon, and I'm extremely sorry uh, that I caused this inconvenience for you all. Okay, I didn't mean to, but yeah, I didn't check the device in which we are executing. We were in CPU. I didn't just notice it. Okay. Yeah, now only it is loading the datasets, so it will take some time, I guess. So until then, if you have any questions, just let me know. But till that time, I'll show you about the inference of this. Okay, so here you can see how to infer it. I'll just show you. Okay, once you push to this hub, okay, so what you need to do is you need to have this specific bot. So this is again a chatbot interface. Okay, I'll explain the code here itself. What it will do is it will try to call the model. Okay, so first what happens is it will try to call the config from here, whichever repo. So here it is Flan-T5 large AIO. So it will try to call the repo, and then the config will be here. The base model will be called again because it is under the name, base model name or path, that under that name in that config, it will be Flan-T5 large. We'll try to attach those. Okay, so that is what happens in PEF model. Okay, so PEF model from pretrain, what it will do is it will try to take this model and it will try to attach the adapters, and we are also inferencing it in CPU. Okay, we are setting the model.eval function because we need to, what is happening? Oh, yeah, forgot it. Here is that 33. So here we need to do these. Let's come on to here. Okay, so we are setting the model dot eval so that we'll know that the model is inferencing it. We are setting it to inference mode. Okay, so the model is set to inference mode and the model and tokenizer is returned. Okay, so that is what happens here. We are setting the cache resource to be true so that this won't be loaded again and again in the application. And if you are wondering, this is a Streamlit application, guys, and I have explained about this code in detail in Flan-T5 LoRA chatbot video. You can check that out. I'm just gonna give a gist of it here. Okay, so in an inference function, what it will do is it will take the model tokenizer and input sentences as its arguments, which we'll provide it from here, obviously. And what we'll do is we are providing input here. Okay, first important thing is try to attach a task prefix and then have your input string. Okay, so once the input string is provided, it will try to tokenize it. It will return the tensors as PyTest tenses, and the truncation will be set to true. And then max length you can provide it on your own. Okay, here it is 128, so I recommend you all to provide it as 128 itself. So yeah, now let me continue here. So what it will do is now you'll have the input IDs, which is your inputs, obviously, and then you need to provide this input IDs to the model. And then once the model gets this input IDs, you are free to generate the outputs. Okay, so what it will do is it will try to generate the output based on these input IDs, which will be your output IDs, and then we'll need to decode it. So that is what happens here. Finally, you'll have a string being returned. Okay, So here it shows 10 minutes. We should have done this prior. So if we had done it, I could have shown you the result as well. But we can't afford that right now, right? We have 1 hour 45 minutes being completed. So yeah, guys, that is how you need to fine tune Flan-T5 for all of your tasks. So in this video, I've shown you how to fine tune Flan-T5 for all the tasks at the same time by using this task prefix. So before inferencing, without forgetting, try to add the task prefix and then fine tune it. All right. So yeah, guys, that's it about this video. I hope you all like this live, and let me know if you want more lives like these in future. And yeah, just I'll update this notebook once this training is completed into the GitHub, and then I'll update that link in the description as well. Okay. So yeah, guys, that's it for this video. I'll see you all in the next video, which is about how to fine tune Zephyr. Okay, so that is an interesting video yet about how to fine tune a powerful model. So hopefully you will all like it, and yeah, just share this video with your friends and communities. Hopefully they will also get some benefit out of this video if you think you benefited from this video, obviously. And like this video, and also comment your suggestions in the comment section. Okay, guys, I'll see you all in the next video. Until then, cheers.